Hello, and thank you for joining us today. Our team is developing an advanced decision support tool to accelerate and standardize the process of identifying parts suitable for additive manufacturing across the Department of Defense. The topic title for this project is the Active Part Filtering for Additive Manufacturing Candidate Identification, otherwise known as AMCI. This STTR project is led by Catherine Ashley, the principal investigator, and Andrew Killian, the project lead, with support from Dr. Nicholas Miesel, associate professor of mechanical engineering from the Pennsylvania State University. Cornerstone Research Group, now doing business as CRG Defense, is a leading aerospace and defense firm based near Dayton, Ohio. For nearly 30 years, we have designed, developed, and delivered solutions that serve the warfighter and scale to meet the future of national defense. Our core competencies span advanced materials and manufacturing, aerospace systems, artificial intelligence, and more. The U.S. Navy faces a critical challenge in modern defense logistics, the time-consuming and inefficient process of manually identifying suitable candidates for additive manufacturing, or AM. This challenge significantly impacts mission system readiness, supply chain resilience, and logistical efficiency. While additive manufacturing offers promise for just-in-time part production, not all existing legacy component designs are suitable for this approach. Determining component candidates for additive manufacturing requires careful consideration of cost, manufacturability, and lead time. The technology developed to address this challenge has a primary transition target of the Navy PEOMLB with secondary targets across DoD prototyping labs, maintenance depots, and engineering centers. Navy additive manufacturing engineers receive AM requests from the fleet, program offices, and reliability control boards, requiring manual evaluation of each part for AM suitability. This time-consuming process demands high expertise and creates a bottleneck in leveraging AM technology effectively. Our AMCI solution evaluates part candidates over 99% faster than the manual process, providing more standardized and reliable estimates for suitability, cost, and lead time. This allows our skilled engineers to focus on more complex, value-added tasks. AMCI is a cutting-edge, cloud-based decision support tool deployed in AWS GovCloud to meet IL4 requirements for DoD use. This human-guided AI software predicts AM suitability, lead time, and cost with remarkable accuracy. We've trained our AI model on manually scored part datasets using a standardized scoring rubric and print and cost models developed by the Pennsylvania State University. In practice, AMCI enables faster, standardized AM candidate identification across both 2D drawings and 3D models, a crucial versatility in a field where legacy drawings often coexist with modern models. We've designed an intuitive, easy-to-use portal where AM engineers can quickly upload part files. Within moments, AMCI delivers a comprehensive evaluation, including an AM printability score, estimated print time, and projected costs. AMCI's machine learning sets it apart from existing solutions. As AMCI is used, it continuously learns and improves, incorporating expert judgments to enhance its prediction capabilities. AMCI has hit several key milestones. We've established our scoring rubrics, designed our IL for AWS GovCloud software architecture, and demonstrated machine learning capabilities for suitability scoring. We're on track to complete our time and cost methodology and 2D part reader capability in fiscal year 26. We aim for TRL4 with our alpha version in Q3 fiscal year 26, progressing to TRL5 with NAVAIR usage testing by the end of fiscal year 26. Our ultimate goal is to reach TRL 6 with our NAV Air tested beta version by Q3 fiscal year 27. We're actively seeking Phase 3 funds and DoD collaborators to bring AMCI to full operational capability. Beyond defense, we plan to implement AMCI in our own additive manufacturing service business for automatic quoting, demonstrating its broad utility and commercialization potential. We've designed AMCI with key features that provide significant advantages to our users. Our tool autonomously identifies good AM part candidates with minimal human input, dramatically speeding up the evaluation process and improving decision-making across the board. AMCI evaluates print time and cost for each part, facilitating comprehensive cost-benefit analysis for more informed manufacturing decisions. The system continually improves its accuracy and efficiency through an actively learned machine learning model as it processes more parts. We've ensured compatibility with both 2D drawings and 3D models, making AMCI versatile for legacy systems and modern design tools alike. Our intuitive and flexible user interface makes AMCI accessible for personnel across various skill levels and departments. As we transition AMCI to the fleet, we're seeking Phase 2 plus funding to complete beta software demonstration and user acceptance testing with Navy AM engineers. We'll integrate AMCI into Navy PLM workflows and secure the necessary authority to operate for operational deployment. Our primary transition advocate is the Navy PEOMLB, specifically the Naval Product Lifecycle Management Program. We're also engaging with NAVSEA, NAVAIR, DLA, and the Air Force RSO to broaden our adoption across multiple services. We're targeting a Phase 2.5 or 3 award for platform and program alignment, aiming for operational deployment and fleet-wide availability in fiscal year 2028. This strategy ensures we meet end-user needs while aligning with DoD acquisition processes. Throughout this transition, we're committed to working closely with our Navy partners, ensuring AMCI seamlessly integrates into existing systems and delivers immediate value to AM engineers across the fleet. Our market analysis reveals significant potential for AMCI beyond defense applications. We've identified commercial sectors that could benefit from our technology, including aerospace maintenance, industrial equipment spare parts management, and additive manufacturing service bureaus. We're adopting a subscription-based license model, offering AMCI as a secure software as a service solution hosted in AWS GovCloud. We're targeting aerospace and defense primes like BAE Systems and Boeing Defense, while also exploring opportunities in medical device manufacturing. We anticipate continued interest from government entities, including DoD branches, NASA, and the Department of Energy. We've developed AMCI as a secure software as a service solution with flexible cloud-based or on-premise deployment options. While our primary transition target is the Navy PEOMLB, we're also engaging with NAVAIR, the Air Force, and automotive manufacturers. We've identified secondary transition paths including Department of Defense logistics organizations and commercial sectors like aerospace MRO operations and additive manufacturing service bureaus. We're seeking partners who value streamlined additive manufacturing processes and want to leverage our advanced AI capabilities. By partnering with us, organizations can significantly enhance their AM part identification efficiency and decision-making processes. This concludes our presentation, and we thank you for your time. We welcome your inquiries and are eager to explore potential partnerships. Please don't hesitate to reach out to Catherine or Andrew for more information about AMCI. We appreciate your interest and look forward to the opportunity to work together in advancing additive manufacturing capabilities for the DoD and beyond.